Hello friends, welcome to Hankies Academy. Today we will start with other topics under basics of network theory, that is inductor and capacitor. So let's start with inductor. Inductor symbol is drawn as this. It can be also called coil. Unit of inductance is Henry. Henry. When we connect a voltage source across an inductor, then a current flow current I flows through the circuit. Now if you look from one end of the inductor marked as A and B, one end of the inductor from an A, you get to see that current is flowing in clockwise direction. This is clockwise direction. So this end can be considered as south pole of a magnet. And from the end B, current will be in anti-clockwise direction. So this would be a north pole of the magnet. There is a short trick to remember how this works. Just redraw N of north like this. And it becomes anti-clockwise direction. Likewise, redraw S of south like this. And it becomes clockwise direction. Now we know that magnetic field travels from north pole to south pole. Magnetic field travels from north pole to south pole of magnet. So the magnetic lines of forces around the inductor would be somewhat like this. From north to south, from B to A. From B to A. These are magnetic lines of forces from north to south. There is one key point which you will rarely find in books, that is, inside a magnet or inductor, magnetic lines of forces travels oppositely to the regular convention, that is, from south to north. Therefore, always remember, from outside magnet or inductor, magnetic lines of forces is from north to south. Outside it is from north to south, and inside the magnets it is from south to north. Now, inductor. Actually, what is inductor? It is an element that stores energy in the form of magnetic field. Stores energy in the form of magnetic field. When current is time variable, then the energy is generally stored during some part of the cycle, and for other part it returns to the source. Magnetic field of inductance circuit is collapsed when the source is removed. In other words, no energy is stored without a connected source. Therefore, we can say that inductor is a frequency dependent element. It is frequency dependent because when current is time varying, then only magnetic field is produced in a coil or inductor. And inductance is the flux linkage per unit current. That means L is inductance is equal to N into phi. Phi is the flux divided by current. Flux linkage is N into phi. Number of turns in a coil into flux produced due to change in current. When current is time varying, then voltage at any time t is proportional to the change in current with respect to time. That means Vt, voltage at any time, is proportional to change in current di by dt same time. And when we remove this proportionality sign, then a constant comes into picture, is equal to L, and this constant is known as inductance. And if we take an equation in terms of current, that means I at any time t, it is equal to 1 upon L into integration of V, voltage, with respect to time dt, and the limits are from 0 to t. It is in time domain. And in Laplace domain, it is Vs is equal to L into d by dt is replaced by S into Is. We will discuss Laplace in mathematics lecture. Now put S is equal to j omega, where omega is the angular frequency. Therefore, V j omega is equal to L into j omega I bracket में j omega. We know that j is 90 degree in angle. We can represent j as 90 degree. That means when we take a current base quantity, then the value of voltage is 90 degree ahead of current. And now these phases, we will draw a phasor diagram. Take a base quantity, current I, and voltage is ahead of 90 degree of current. degree. When any network is analyzed in S domain, that means in Laplace domain, then any differential and integral equations are transformed in linear equations, as we see above, and manipulation becomes simpler. This is a linear equation. An initial condition, if any, are taken automatically, which we will discuss later during numericals. Now, inductor is a linear element. As we will discuss earlier in resistor, that the variation of the terminal voltage and terminal current is linear either in time domain or in S domain or in both. linear graph between current and voltage. Inductor is also a bilateral element. Which means current flows in either direction of inductor, irrespective of the type of polarity of the voltage. This is all about the inductor. The key points to remember for inductor is that in inductor voltage is always leading the current. Or we can see that by 90 degree. Or we can say that current is always lagging the terminal voltage. By 90 degree. Current lags the voltage by 90 degree only when the inductor is pure the value of inductor is pure inductance, not included resistor. And second, inductor always stores energy in the form of magnetic field. Now, there is a question for you. The number of turns in the coil is 250. When a current of 2 ampere flows in this coil, the flux in the coil is 0.3 milliweber. Find the value of inductance and also find the voltage induced in the coil when this current is reduced to 0 in 10 milliseconds. We are given that the value of turns is 250. Value of current I is 2 ampere. The value of flux phi is 0.3 milliweber. Now, we know that inductance L is equal to N into phi by I. Put the values. 250, L is equal to 250 into 0.3 divided by 2. From this we get the value of inductance is 37.5 millihenry. Now the second part of the question is to find voltage induced in the coil. So let's take the equation. Voltage V is equal to L di by dt. Put the value. 37.5 and the value of current is from 2 ampere to 0. That means 2 minus 0 in 10 milliseconds. Then the value of dt is 10 milliseconds, which gives the value of voltage is 7.5 volt. That's all. Now come to the second topics of today's lecture, that is capacitor. The symbol of capacitor is unit of capacitance is farad. A capacitor is an element that stores energy in the form of electric field. When voltage is variable, then energy is stored as a charge in capacitor for 1/2 of the cycle and returned in next. Capacitor stores energy by displacement of charge. That's why when we remove the source, energy is retained. Removing the source, energy is retained in the capacitor. While an inductor cannot retain energy. An inductor cannot retain energy after removal of sources because magnetic field is produced only due to presence of current change with respect to time in the circuit. The charge condition of capacitor can retain until a discharge path is provided, through which energy is released. Capacitor is the combination of two parallel plates. When it charged, then there is an excess of charge on one plate and deficiency of charge on another. Excess of charge on one plate and deficiency of charge on other. And when the capacitor is discharged, then the equalization of these charges take place. This condition is charge condition, and when capacitor is discharging, then the equalization of charge take place. That means equal charges on the two parallel plates. Capacitor is the proportionality constant when current at any time t is proportional to the change in voltage with respect to time. That means IT is proportional to dVt by dt. Divided by dt. And when we remove the proportionality sign, then I is equal to C dVt by dt. Now this is capacitor. Now take Laplace of the equation. Then Is is equal to C into S Vs, where d by dt is replaced by S in Laplace transform. Put the value of S is equal to j omega. Therefore, the equation becomes I j omega is equal to C into j omega into V j omega. And we can also write this as V j omega is equal to 1 upon j omega C into I j omega. Now we know that the value of j can be written as 90 degree in angle. That means when we take voltage a base quantity, then the value of current is 90 degree ahead of the voltage. From this equation we can see that when we take a base of voltage, then current is 90 degree ahead of voltage. This is the phase difference 90 degree between voltage and current. The charge stored on capacitor is proportional to the voltage applied across it. That means Q is proportional to V. When this proportionality sign is removed, then capacitance comes into picture. This is capacitance. Thus the formula becomes Q equal to C into V. Now Q equal to C into P. Capacitor is a linear element. That is, the variation of terminal voltage and terminal current is linear either in time domain, it is linear either in time domain or S domain or in both. Capacitor is also a bilateral element. Which means current flows in either direction of capacitor irrespective of the type of polarity of the voltage. But only electrolytic capacitor is unilateral because electrolytic capacitor is unilateral. Because voltage is fixed for this type of capacitor and it can be charged only once. This is all about the capacitor. The key points to remember for capacitor is in capacitor, voltage is always lagging the current. Or we can say that current is always leading the terminal voltage. The second is capacitor always stores energy in the form of electric field. Always stores energy in the form of electric field. Now come to the question. Question is how much charge is stored in a capacitor of 2.0 microfarad when a voltage of 5 volt applied across it. Given is charge Q capacitor is equal to 2 microfarad and the voltage is 5 volt. Now from the equation we know that Q is equal to C into V, that means capacitor into voltage. Put the value of C and V, which is 2 and 5. The value of charge is 10 microcoulomb. That's all. Now all the three elements, resistor, inductor and capacitor in a circuit is known as impedance. Inductor and capacitor impedances are called reactance, which is represented by XL and XC. The representation of impedance in terms of inductor, capacitor and resistor is Z. Z is the representation of impedance. Therefore, the Z is R for resistor circuit. Resistive circuit. Z will be XL is equal to J omega L for inductive circuit. And Z is equal to XC is equal to 1 upon J omega C for capacitive circuit. That's all for this lecture. I have tried to cover every possible topic related to the basics of inductor and capacitor. Now, there are two homework problems. Question number 1 is, the number of turns in the coil is 120 when a current of 24 ampere flows in this coil. The flux in the coil is 0.9 milliweber. Find the value of inductance and also find the voltage induced in the coil when this current is reduced to 0 in 8 milliseconds. And the question number 2 is, what is the value of capacitance when 24 microcoulomb charge is stored in a capacitor when 8 volt is applied across its terminal, and also find the value of current that flows through the capacitor when this voltage is reduced to 2 volt in 10 microseconds. Comment your answers in comment box. For further videos, subscribe to our channel Hankies Academy. Thank you.